full 45 minutes. All right, guys, so what we're looking at today is the difference of perfect squares. So this here is another type of factoring. And this works if we have two terms or two numbers that are perfect squares, something times themselves, and they're being subtracted. So this is called the difference of perfect squares. And whenever we have this, it's going to factor to the form a plus b times a minus b, where a is the first term that's being squared, and b is the second term being squared. So if we looked at an example of this here, so it'd be like x squared minus 9. Where x, well, the x squared is x times x. That's where we have that there. Now, 9 is 3 times 3, or 3 squared. So we could rewrite it as x plus 3 times x minus 3. Now, if we look at our first example, we have this here, x squared minus 25. Is x squared a perfect square? Well, yeah, it's x times x. What times itself is 25? 5. So what we could say is this is x squared minus 5 squared, kind of going in the form of a squared minus b squared, which is our a plus b times a minus b. Because in this case here, a is going to be our x and b is 5. So we would have x plus 5 times x minus 5. That's it. Any questions on this here? Let's look at the next one. 4z squared minus 1. Well, what times itself is 4z squared? 2z, because 2z times 2z is 4z squared. So we could say it's 2z squared minus, what times itself is 1? So kind of keeping into that form of a plus b times a minus b. So here our a term is 2z plus our b term is 1. And then we would have 2z minus 1. Because it's what goes in the first spots is going to be whatever the first term is when we take the square root of it, or we find out what times itself would give us that. And then whatever number times itself gave us our second term goes in the spot where b is. So let's look at the next one, x squared minus 64. So what times itself is x squared? X, and then 64 is? So what would this be? Because what times itself is 64? Mm-hmm. So then this would factor to what? Mm-hmm. And that's what's nice about the difference of perfect squares, is because both terms are perfect squares, and it'll factor like this way every single time, whenever it comes in the form of a squared minus b squared. So 100 minus m squared. Because 10 would be for 100, yes, and m is m squared. So this would factor to what? We put the 10 first because the 100 came first. Because 10 times 10 is our 100. Since it came first, it'll go first. Since m came after the minus, it's going to go second. So I said m plus 10, and then m minus 10. Well, let's look at this here. Are these two here the same? Yeah, 10 plus n, m plus 10 are the exact same. Are these two here the exact same? So we would get it halfway. Because 10 minus m and m minus 10 are different. Now, there is a way to adjust for this to make them be the same. Because we can put a negative out front to make it be the same, which is essentially taking the second set, our 10 minus m, and factoring a negative out. Because if we factor a negative out, it will make the m go from negative to, and the 10 go from positive to negative. But if the term is second, keep them second. If the term is first, keep it first. Because it's very tempting to want to put m first, because that's what we've been doing and what we've been in the habit of, but we put it wherever it's positioned. Let's do this one here, and then I think y'all feel pretty comfortable with these, yes? Yeah, so you have it almost right. You just left off the 3 for our 9.
So then when it's like that, I would divide whatever it is.
So in 9n squared, because n squared is n times n. What times itself is 9? 3 and 3. Because 3n times 3n would be 9n squared.
Yeah. But like if you didn't know what like.
Because for all these here, we're looking for something times itself, yes? What is one operation that would tell me that? We could take the square root of, and see what it is. We could take the square root of 16. It'll tell me this is 3 and this is 4. We can't use the variable, because, I mean, we could do it by hand. 3, because 9n squared. Well, we know n squared is going to come out as n. I can't type that into a calculator. At least the 30XS and the TI-84 plus these, they need a value for that variable. They have to have a number put into it so it can figure it out. It doesn't take it as a variable. Any other questions on these here? Let's look at the last part. So we want to use this property to evaluate this here. Well, what we said is a squared minus b squared is equal to a plus b times. So here we have 54 squared minus 48 squared. So we could say that this. Because we could say it as 54 plus 48 times 54 minus 48. Because this here is an easier way to do it, because if we try to figure out what 54 squared is, that's going to multiply 54 by itself, which is going to be a big number. Here, 54 plus 48 is going to be, and 54 minus 48 is? Now we can multiply these together. 6 times 2 is 12, so 2 carry the 1. 6 times 0 is 0, plus 1 is 1, and 6 times 1 is? So 54 squared minus 48 squared is 612. Yeah.
So let's say like 68, 62, you would add those together.
Well, 68 plus 62 is?
I need the following students to come to the office. Anne Marie
And then we do 130 times 6. No. So 780. So Quincy, so you're just typing in 68 plus 62 and doing it that way? I mean, yes. Let's clear that out. Let's look at the next one. Is what? 36 minus 34 squared. So I'm guessing 36 minus 34. And you were getting that answer? And then 36 plus 34? And then we're doing 70 times 140. I mean, what we could do is say 36 minus 32. 36 plus 30. I think I'm doing 32. Parentheses. Or the last one.
Well, because I have to do it like this because I feel like you're just going crazy with the big and the negatives.
Well, this here, all we're doing is exactly what we did on the previous problems, isn't it? With factoring. It's just applying numbers to it. Y'all ready for the next hard part?
That shouldn't be so hard, right? Oh! You're being sarcastic.
Yes. Because our next piece is?
Well, this one is